Okay, question number one, it's a limit problem, limit as x goes to infinity. So let's take a look, and let's see if we can evaluate this quickly. Remember, on a multiple choice exam, you're not being graded for the work, you're being graded for the choice. So as x goes to infinity, the top would be e to the 0. The bottom would be 2 plus e to the 0. Well, e to the 0 is 1, and then you get 2 plus 1, and that's going to be 1 over 3. Is that answer being listed? It is. It's selection D. Let's go to the next one. The next one says, given the graph, I do see it, it says, which of the following statements is false? Well, let's take a look at the first one. The limit as x approaches 2. And I want to claim to you over here, I'm noticing this is 2 over here, and from the right of 2 and from the left of 2, it's going to infinity. So this one's correct, all right? The next one, the limit as x approaches 3. Well, let me get my eraser out. Erase the my writing on this over here. I want to get rid of that. And I'm going to talk about going towards 3 now. And if you go towards 3, this is 3, the limit would be this thing over here, all right, which would be 2. So this one should be circled over here. Now I want to look at the other ones. That's a false statement, by the way, because they're saying it's 4. It's not 4. The limit as x goes towards infinity, well, it does look like 1 over here. I'm going to say that's correct. Go towards minus infinity. Again, looking over here, it does look like it's 1. Over here, the domain, they say is from minus 5 to 2. And, you know, with the assumption that you believe this is going on forever, yeah, that's true as also. So B is the correct answer there. B is the only false statement. All right, let's go to 3. 3 is a piecewise function, and being a piecewise function, you'd have to be able to understand the limit comes from 2 sides. So limit as x approaches 2 from the left side, well, that would be 4x minus 3. I'll do that in a moment. And the limit as x approaches 2 from the right side, and that would be x squared plus 8. Now for the limit as x approaches 2 of f of x to exist, those two limits would have to agree. And what do you get over here? Well, 8 minus 3 is 5. And this one's going to be 4 plus 8 is 12. So this is a DNA. It doesn't agree. All right? Is that choice listed? It is. It's choice E. Let's go to the next one, number 4. Number 4, there's a couple of different ways of doing this. One is to recognize that it's actually the definition of the derivative, or just simply expand it. I'm going to expand it first. I'll put this down, limit as h goes to 0. This is h in the bottom. And what do you get there? You get 9 plus 6h plus h squared. I just did this part over here. Minus 5. I'm sorry, minus 15. I'm sorry about that. Let me just go backwards on that. So minus 15 minus 5h, and then plus 6. What do you get over here? Well, if you look at this, 9 minus 15 plus 6 is 0, and then you get 6h, and minus 5h is just h. Then you get h squared. Whoops, forgot to put the limit down. H goes to 0 over h, and this would give you, let's see, limit h goes to 0, 1 plus h, that would be 1. That's answer A. Let me talk about the other definition, the definition of derivative. So f prime at A, this sort of looks like that. The limit, I'm seeing the h by the way, so I'm saying that. And then I'm going to say, 3 plus, whoops, you know what? Maybe I shouldn't have written that down because I'm assuming I can do that. Let me just go backwards again. It would be f of A plus h minus f of A, all right? So I'm going to say that looking at it, and again, this might confuse you, but looking at it, it sure does look like that, with the understanding that f of x is going to be x squared minus 5x. Let me just check it out, by the way. F of, oh, by the way, I should put the a down too. The a appears to be 3. So f of 3 plus h would be 3 plus h squared minus 5 times 3 plus h. There's one thing to check out, though, that f of 3, which is the a in the problem, actually equals what they said is 6. Let's put that down. It's going to be 9 minus, when I should say it equals minus 6, because minus 6 plus 6. That's going to be 9 minus 15, which is minus 6. So yeah, this is fine. And you can take derivative now, so f prime. Again, if this confuses you, not a way to go. Minus 5. And f prime, this is going to be at 3. Whoops. What's that going to give you? 6 minus 5, which is 1. Yeah, same conclusion each time, by the way. Let's do the next one. This is a more difficult one, and I'll tell you why. Looking at it, x is going towards the 1, so the top and bottom are both going towards 0. I would claim that this is best to use L'Hopital's rule to do that. And this goes, x goes to 1, ln x. As x goes towards 1, ln x goes towards 0, and x4 minus 1 also goes towards 0. So I'm going to use L'Hopital's rule. I put a little h above the equal sign, and I write down limit as x goes to 1. The derivative top is 1 over x. The derivative bottom is going to be 4x cubed. And if you took that limit there, it's not that bad. You get 1 on top, you get 4 on the bottom, which is 1/4, which is a. Now, the other way of doing it, which we won't do at Essex, by the way, is by using numerical tables. And the way I would do that, I would put a right table and a left table down. I'm going to say it's a left table. The left table, you're going to get numbers that are close to 1. Like, what's a good number? I'm going to say 0.9 from the left, and then 0.99, and 0.999. And I hope you realize these are definitely going towards 1, but from the left side, right? Then you put f of x down, which is just simply natural log of x over x4 minus 1. But it requires a calculator. But if you were to put a calculator computation on here, they sure do look like they're going towards 1/4. Then you put the right-hand table down. And again, the right-hand table is still the same function. And this is right, RT. What's to the right of 1? Like, if you put down, like 1.1, and then put 1.01, and then 1.001. These are definitely going towards 1, but from the right side of it. And then if you put these numbers over here, one after another, they sure do appear to be going towards 1/4. All right? I think L'Hopital's rule is the way to go on that one because we don't use calculators at Essex County College. Let's go to number 6. Number 6 is show your work. And this is where the results are not necessarily being graded as being right or wrong. There's going to be work associated with this over here. So this is as you go towards infinity. And what I notice immediately, it looks like infinity minus an infinity, which I'm not sure. It's indeterminate at this point. So what I want to do is write down limit. I'm going to put work down now. X goes to infinity. And the way we do this, we're going to multiply by conjugates. So it's going to be root of x squared. Let's see, plus 20x plus 1 minus the square root x squared plus 8. And I'm going to multiply top and bottom by the top's conjugate. And this is going to be x squared plus 20x plus 1 plus the square root of x squared plus 8. And again, top and bottom there. All right, let's take a look at it. We get limit. X goes to infinity. And we're hoping for the best, by the way. What are you going to get? It's conjugate. It makes it a little bit easy on top, by the way. And I will simplify that in a moment. The bottom's still that nightmarish root problem. Let's put this down. Limit. X goes to infinity. The top is just what? X squared minus x squared. That disappears. Then you get 20x. Let's make sure I'm doing this right. X squared minus x squared is nothing. 20x. And then 1 minus 8 is going to be minus 7. And what's on bottom? It's still that root problem. Again, the point of doing this, hopefully it makes it easier for you. Now, as x goes towards infinity, I have to start to realize there's variables on top and bottom. And the highest degree variable on top is actually x. But the highest degree variable on the bottom is actually the square root of x squared. right? They're both equal to x as you go towards infinity, so it's pretty safe to just simply divide through by x or the square root of x squared. So limit as x goes to infinity. I'm going to divide the top by x. I would get 20 minus 7 over x. On bottom, I'm dividing through by the root of x squared. And what are you going to get? 1 plus 20 over x plus 1 over x squared minus the square root of 1 plus 8 over x squared. And can I do that limit now? I can. The top becomes 20, and the bottom becomes, let's take a look at that. You're going to get root of 1 minus, I'm sorry, that's a plus sign. I made a mistake there. Plus 1, sorry about that. So 20 over 1 plus 1, which is 2, which is going to be 10. So the answer would be 10 there. And that's the work supporting that, all right? So let's do the next one. The next one I'm looking at, again, I'm looking for what the work would be. And what I would do, like immediately, it's a complex fraction, is multiply the top and bottom by the minor LCD, which is 5, and then x plus 1. 5, x plus 1. What do you get over here? Limit. X goes to 9. The bottom I'm seeing x minus 9 times 5 times x plus 1. Again, I'm trying to just simplify it at this point. What do you get now? You get 10, and then you get minus, let's see, the 5 would cancel off. You'd get x plus 1 in parentheses. Let me see if I can keep going with this. Limit, x goes to 9. I'm going to write the bottom a little bit differently. I'm going to write as 5, x plus 1, and x minus 9. And on top, what do you see? Well, I see 10 minus x minus 1, which is 9 minus x. Now, I immediately notice that the top and the bottom really don't have a factor in common, but they have a factor that's in common opposite. So let's write this down over here. X goes to 9, minus 1. This should be x minus 9, and this is going to be 5. I'm factoring a minus 1 from the top, by the way. This is x minus 9. This cancels, and the reason it cancels is x is not 9. And what do you get over here? Minus 1, and then you get 5, and 9 plus 1 is 10, so you get minus 1 over 50, and we're done with that one. All right, let's keep moving. Over here, I would say probably factoring this thing. This x goes to 10, and the factorization on the bottom is x minus 10. The top is a difference of perfect cubes. That's x minus 10, x squared, plus 10x, plus 100. That's a difference of perfect cubes, by the way. Since x is not 10, these cancel off, and I'm left off the pretty easy limit, by the way, because I'm just plugging in the 10 limit laws. I get 100 plus 100 plus 100, which is 300. Another way to recognize this thing is to recognize it as a derivative. However, that's probably more difficult to see, by the way. So I'm going to say it looks like the definition of derivative, f prime at some value a is going to be equal to the limit as x goes towards a, and then we write down f of x minus f of a over x minus a. So I'm saying it sort of looks like that, but the question is, what's f of x? F of x appears to be x cubed, and what's the a in this problem? It appears to be 10. All right, so what's f prime? F prime of x is 3x squared, and what's f prime at a, which is 10? It would be 300. Right, so either way you see it, it's 300. Go to question number 9. Question number, looking at it, you're going to 2 from the right side, by the way, and I noticed that, just plugging in 2, forget about right or left, by the way, that I get 0 in denominators in both cases, by the way. Let me just check that. 16, let me make sure I said that right. 2, that's 4, 16. Yeah, 16 minus 16 is 0. There's 0 in both cases over here. So my gut feeling is it's probably going to be something where I need a common denominator. Again, I know I got something to do over here. And I'm looking at it, and I'm going to say x minus 2. And then I'm going to say x, whoops, not x. Let me go backwards on that. I'm going to say 4x, and then minus 3. Let me just check it, by the way. I do get 4x squared. Let's see, minus 3 No, I made a mistake, plus 3. Let me just check that again. So I get the 4x squared, 3x minus 8x minus 5x. I do get minus 6. So I'm good to go. It's going to be 5x plus 1 minus 1 times 4x plus 3. And again, I'm not going to say it helps much, but I'm going to simplify the top now. And I bet something nice is going to happen. And what do you get there? You get 5x minus 4x, which is x. And then you get 1 minus 3, which is minus 2. And yep, something nice happened. Since x is not equal to 2, these got to cancel off here. So limit x goes to 2 from the right side, 1 over 4x plus 3. And can I do that? I sure can. And what do you get over there? You get 1. I'm using limit laws now. That's going to be 8 plus 3, which is 11. So 1/11. All right, let's go to the last problem, number 10. And number 10 is a limit where we're approaching 4 from the right side. And looking at that, one thing I do notice about it, it's 1 over the natural log, right? So the limit at the top is pretty easy, just 1. And the limit at the bottom, what are we doing? It's x minus 4, and we're going towards 4 from the right side. So what I want to point out over here, if that's the case, that this thing here, if it's 4 to the right side, this should be going towards 0 from the right side. And the natural log of 0 from the right side would actually be minus infinity. All right, the natural log is streaming down like this over here. And I realize that 1 divided by minus infinity is going to be 0. So let me get my eraser out. Oops, I didn't mean to do that. I meant to get my eraser out. And let me start to erase things I don't need. Again, looking at this, 0. All right, I realize people are going to argue there's no work over there. If you want to put work down, what you could do is you could write this over here, equals, and let me write this over here, 1 natural log limit as x goes to 4 from the right side, x minus 4. Kind of like, a lot of work here. And then start to realize that, looking at this over here, and again, I hate to even write this down, 1 over the natural log. This would be 0 from the right side, and then you'd write down 1 over minus infinity. And again, I wouldn't do this on an exam, by the way, and this is going to be equal to 0. Right? I would just simply say it's a simple limit, it's equal to 0. Now granted, some teachers let you use calculus for these things over here, and if that were the case, I would be doing a table. I'll put this down for you. This would be work, by the way. F of x, what's f of x? It's 1 over the natural log of x minus 4. You're going to pick numbers to the right of 4, like 4.1, and then you get 4.01, and then you get 4.001. If I looked at that, I'd say, oh, you're going towards 4 from the right side. And over here, it's a computation. And what's the computation going to be here? It's going to be 1 over the natural log of, let's see, 4.1 minus 4 is 0.1. I think you get the idea. 1 over the natural log of 0.01, and that would be 1 over the natural log of 0.001. And by the way, if you did the computations, you would say this is going towards 0, right? By the way, it goes towards 0 through negative numbers, but that's incidental. It's going towards 0. Thank you.